Hey, my name is Rishi Narendran, and this is my Physics 2212 Lab 1 submission for the charge tape lab. So first I want to walk through some of the key tenets of the lab document, and then we can talk about my personal thoughts on the lab and how I presented my results. So first I want to talk about just a couple of things we did in the lab. So in this lab, we basically folded a piece of tape in this shape, and we created a kind of base tape and U tape. And when we pulled the two tapes apart, the two tapes repelled each other because of the charges and electricity at play. And we kind of talked about that. So um, we kind of did these experiments for the attraction and repelling. Um, and we kind of use those observations to construct some computational models and also learn about electricity and magnetism on like a really introductory scale. So I'm going to give you guys my introduction to the lab, and we can go from there about how things went. So to me, this lab focused on exploring concepts of electric charge, and we know this to be a fundamental property of matter. The goal of the lab was to estimate the amount of excess charge on a piece of Scotch tape using the experiment I defined. And the key principles that we used include charge transfer, like how electrons move between objects, interactions between charged objects. So when we put our hand towards the tape, or how the two tapes interact with one another, and approximating those interactions using Coulomb's law, which we know to be F is equal to K Q1 Q2 over R squared. So the lab had some purposes and also some assumptions we had to make to both make the lab simple and computationally viable. So we had to determine the approximate charge on a piece of clear tape using observations and basic physical principles. Some of the key principles we used were assuming that the lab's um, net electric charge can be concentrated at a single point for simplicity. We also use Coulomb's law for the force between the two charges, and this is going to come into play when we talk about how we did this computationally. So this is our glow script code that we use to create a computational model. Um, but in the process, we had to make a couple of key assumptions. So first, we say that the gravitational force and the electric force acting on the tape or acting on the interaction between the tape are equal. Um, then we use F equals QE. So we say that the net electric force coming from all the electrons is equal to the charge of an electron times the number of electrons there are. That way we're able to kind of determine um, that way we're able to determine just the charge on the tape alone. And we're also able to determine the number of excess electrons at play. Um, Using this glow script code, we're able to get this computational model result, which tells us the charge on the tape and the number of excess electrons. Keep in mind that the number of excess electrons is coming from the equation um, Q over EQ is equal to the electron count because we rearrange the force on electrons and the charge from one electron. So this lab ultimately led to some conclusions and also some um, food for thought in terms of the discussions. So some key findings that we were able to make is that when we set the gravitational force equal to the electric force, we're able to derive some important information. And computational processes allow us to model this behavior in a big way. One key thing to note is that as a lab group, we definitely had some questions about how air resistance plays into things and how some of the assumptions we're making can impact the data. Because when we're dealing with stuff on such an atomic level, does ignoring air resistance matter? And does when we talk about assuming that things concentrate at a point charge, does that matter? We didn't really know that, and I think that maybe further in the class we'll learn about how some baseline assumptions can hamper the accuracy of the data and to what extent it can. Thank you guys.